my second state ODE is, if I say x2 dot is going to be, maybe just to show this better, let me say that this has some extra terms in there. Minus g by m minus x plus, let's make this a nonlinear ODE, something of it, just for fun. X dot of t, x2 dot of t is nothing but x double dot which is that creature there, which will have now be written in terms of the x1 dot and x2 dot. So this is going to be minus x1 minus plus x2 squared minus g by m. This is a state space representation. Am I making sense to everybody? I have a second order ODE. I have two state variables, x1 and x2, which is now called as x and x dot, called as x1 and x2. The state space representation of a dynamical system is a set of first order ODEs in the state variables. And you see that these are my state variables. And why is this of use is, at least for us, very narrowly speaking, here is what typically MATLAB does. Okay? So let's say that you are using the Euler scheme for solving, is the easiest example to give. So Euler scheme is this is the Euler scheme, the forward Euler scheme. Okay? For solving ordinary differential equations numerically. MATLAB solves all of these numerically, unless you give it the solution, full form solution, by typing it in there. So everything is solved numerically in MATLAB. This is the first order Euler scheme. Okay. This is x of t at the time t plus delta t. This is x of t at the previous time. This is the function evaluated at the previous time. So if I give initial conditions, supply, you supply initial conditions, you write the system ODE in the state space form in MATLAB, and here is exactly what MATLAB does. Takes the second equation and starts evaluating it at the next instant in time. Okay, so it goes forward in time by a small increment. So x2 dot is modeled as or x2, I'm sorry, x2 at some time t plus dt in increment is written as x2 at time t plus h times x2 or t naught, I'm sorry, this is x naught and t naught. I'm all over the place. This is x naught and 0 h times f at x naught and t naught. So this is essentially solving the second differential equation here. We're making use of this scheme. Okay, so it's going to solve this guy first by substituting for the initial values here, marching forward in time by using a small step size, which you control essentially. And once it solves for that, then you can also simultaneously solve this equation by the same scheme, marching forward in time, giving it a small time step, and that's typically what MATLAB solves. Solves it in parallel. Solves one, goes to the next one, solves one, goes to the next one. Use a solution from the previous to go to the next step in terms of time increments. Okay? I'll stop here. What we will do in the next class is we will set up a problem and try to solve it using MATLAB. Okay? Thank you very much.